Let's talk about the influence of test-driven development on agile development and sustainability. It is nerve-wracking to even think, even imagine that we would do something that would probably take a little bit more time when we already struggle to release projects. We are behind schedule all the time. We got enormous amount of complexity to deal with, and the scope only seems to be ever creeping along. So how would we possibly justify writing anything more than the absolute necessary code should we really want to spend time writing test cases? Sure, this is a bit counterintuitive if we think about it along those lines. But let's talk a little bit about where we are and what we try to do. Let's talk about agile development. What's agile development? Go ahead and ask people what is agile development, and I'm sure you'll get as many answers as the number of people you ask. Well, to me, agile development really trickles down to one single word, and that word to me is the word feedback. We develop something, we show it to people, have them exercise it, and based on the feedback they provide, we come back and improve on what we have developed and enhance the features and add more functionalities. So to us, this feedback loop is extremely critical. Well, when it comes to projects, the feedback loop is what really helps us to create relevant working software. It's not important to just create software. It's not important to just create working software. It's important to create relevant working software. How do we know the software is relevant? Well, one way to do that is to make sure we get this adequate feedback from customers and potential customers and say, is this serving your needs? Does it provide value to you? Is it usable? Is it intuitive? A lot of these things we can get feedback, and based on the feedback we can come back and build, and we can continue to develop. There is another thing we need to be very careful about when it comes to taking requirements and then working towards implementing those requirements. So I'm going to say, if your objective is to build what your customers and customers wanted, you will fail. So you cannot afford to build what your customers wanted. You need to build what they still want. And this is one of the biggest challenges. You want to ask them what they want, but by the time the product is complete and delivered, what they actually want in the end may be very different in several ways compared to what they wanted. So we need to have this feedback loop going so that we ask them what they want, but continue to interact with them and end up delivering something what they still want. So we can't really deliver what they once wanted. We should be delivering what is still relevant to them and useful. So this critical thing, this feedback is extremely important. But there are two circles of feedback. There are two very critical different ways to consider feedback. Now, depending on organization, some companies get into agile development because the programmers got together and got excited about it, and then they started doing agile development. In other companies, they started doing agile development because a bunch of people at the leadership level, management level got together and said, we are going to push agile. And the feedback loops that you see often depends on who the predominant driver is. So what are these feedback loops in general that we are talking about? Well, one feedback loop that we are talking about here is that the code is meeting the programmer's expectations. So the code, the inner circle that you see here, is the fact that the code is meeting our expectations as programmers. That's one circle of feedback. The other circle of feedback, I call it the circle of relevance, is to make sure that the code is meeting the customer's expectations. Now we could ask which of these two is important. Well, both of these circles are extremely important. If we only focus on the inner circle, maybe we are a bunch of programmers who got together and started doing agile development, and we are taking on some practices like XP or test-driven development. Well, we focus keenly on the inner circle, and we tend to forget, let's say, the outer circle. Well, this would be an example of taking the proper measures and doing very correctly what shouldn't be done in the first place. So it's not important just to develop the software right, it's also important to develop the right software as well. So as a result, as much as the inner circle is important, we cannot ignore the circle of feedback, the circle of expectation. Now, what if an organization only focuses on the circle of expectation and they don't really provide these technical practices? This is typically when the management got excited about agile development, follow things like Scrum, but they don't really pay enough attention or detail to the technical practices. Well, in this case, they're going to focus on the meeting the customer's expectations. But what happens in this case is, as the application is being developed, as the feedback is being received, we are not able to sustain with this development. How so? Well, let's imagine for a minute that I'm a project manager, and here I have a team of wonderful programmers who are extremely good at writing code. Let's say here I have some customers who are eager to receive this software. I take on the first sprint, I go to my programmers and say, here are the features we need, let's go implement it. The programmers crank out code very quickly, and then I take this and take it to the customers and say, ta-da, here's what you wanted, we have developed it, take a look at it. Well, the customers look at it. Has it ever happened to you that the customers look at this and then after they look at it, they walk over to you and hug you in tears and say, this is exactly what I wanted. Thank you so much for doing it. Well, that doesn't seem to happen, is it? Well, oftentimes they say, yeah, that looks all right, but this is what we really meant. This is what we really want. We want you to change this. We want to change that. Well, you take all these change requests, and come back to the programmers and say, could you please make all these changes? And while you're at it, go ahead and make these enhancements, add these features. The programmers, being really good programmers, crank out more code, make those changes. We take that back to the customers and say, what do you think? And the customers look at that and what do they say? Well, wait a minute. This one was different last time, wasn't it? This worked differently last time. Well, this worked better last time. Oh, this one is completely broken. Sounds familiar? So it feels like 2 steps forward and 7 steps backward oftentimes. Well, there's a name for this. Those of you who have kids, or those of you who have been kids, know what I'm talking about. If you go to the stores, like for example Chuck E. Cheese, and they have this wooden table with a wooden hammer, and kids love playing this thing called whack-a-mole. There's a random mole that pops up. The kids take a hammer and take a whack at this mole, and arbitrarily another mole pops over there, and they take a whack over there, and the kids love playing this whack-a-mole, and then these kids grow up to become programmers, and we end up creating what's called the whack-a-mole software. Well, it's very frustrating for the customers if they have to track this whack-a-mole software. It becomes extremely hard to really manage this project as well. So the outer circle is extremely important, but the outer circle collapses, the feedback loop collapses quite quickly if we don't have the inner circle. So this is evident in a lot of different projects where the sustainability is really at stake when team ignores these practices that can help develop sustainable software. And so as we go through this feedback loop over and over and over, unfortunately we don't get benefits out of it if we don't have the inner circle of feedback. So for our agile development to be successful, we definitely want both of these circles of feedback available to us. That becomes extremely critical. So it's not about speed, but it's about sustainable speed. It's not about running really fast, but it is able to run really fast in a sustainable manner in the right direction. That becomes extremely important. But having said that, with respect to test-driven development, we are writing test cases and then we are writing code along with test cases. Now, obviously, to write these test cases, they don't come for free. It's going to take time to write these test cases. So what's the cost of writing these test cases? Well, there is some cost, but there are 2 kinds of cost involved here that we should really be careful about. One is the cost of testing, and the other is the cost of learning. So let me cover both of those here. What is the cost of testing? What is the amount of time and effort it's going to take to write these test cases? Well, clearly it takes time to write these test cases. There's no doubt about it. But how much is it? Well, it's really hard to quantify that particular time. It takes a certain percentage of time. But if we make it a practice to write code and write test, we don't have to really sit there and say, this is how much time it takes to write the test and here's how much time that takes to write the code. It should become a very natural process for us to write code and test. For example, you don't sit there and say, here's how much time I take to think and here's how much time I take to type. Here's how much time I click on the button to save the file or to compile it. Well, it's part and parcel of the whole thing, and you're trying to improve on the entire sequence of things that are necessary to write code. You don't really say, well, to create a very good variable name, I need this much time. To define a class with a good name, I need this much time. Well, that is part of design and coding, and testing should become naturally so. But if you're looking at numbers, for example, Dr. Laurie Williams at North Carolina State University did a research. She gathered up a group of professional programmers. These were programmers from well-known companies in the world, and she brought them over and said, well, I've got a program here, a problem here. Go ahead and write a program for this. So there was team 1 and team 2 asked to do this particular work. When both the teams were asked to do the programs, team 1 was told simply to go implement the solution. Team 2, on the other hand, was required to write fairly good amount of automated tests on this code. Well, both the teams went on to write code, and you can imagine who came back first. Team 1 came back first. Team 2, on the other hand, took 16% more time to complete this particular code. If we stop right here, we could argue that team 1 came out winning compared to team 2. Obviously, they took less time to work on this. However, when both the teams eventually came back, she took the programs and found that team 2's code worked fairly well for what it did. There were a few issues with team 1, but then she asked them both to make certain changes and improvements to the program. Well, this time around, guess who came back first? Team 2 came back first, and team 1 was still working. And when eventually team 1 completed, there were so many bugs in the code compared to the work done by team 2. So what this shows us is, even though initially it takes a little bit more time to develop a code with automated tests, in the long run we actually benefit. So this is something for us to keep in mind when it comes to cost. This goes back to the old days of Toyota, before Toyota got its reputation and name for quality, and they used to manufacture cars at a certain cost. Well, they found out that in this particular case, their maintenance cost was way more than their manufacturing cost. And they found out that while they're able to create cars fairly well, their cost of maintenance, things were coming into shop more often, taking more effort and time to fix, more money cost as well. And they found out that by improving the quality of what they do, they ended up actually increasing the manufacturing cost just a little bit. But as a result of that improved quality during manufacturing, they found out that they were able to reduce the maintenance cost in the long run. So in other words, the maintenance cost before this particular change was much greater than the maintenance cost after the change. So the bottom line with this really is, the question to ask is, do you really want local optimization, or do you really want to do global optimization? So local optimization is where I'm interested in just reducing the programming cost. Global optimization is, I'm interested in reducing the overall cost of developing and maintaining the software. If I try to reduce my cost and time of development, I may increase the cost of maintenance in the long run. But as a company, as an organization, we should ask ourselves, are we interested in lowering just the programming cost, or are we interested in lowering the cost of developing and maintaining this software? Local optimization versus global optimization. Well, we cannot just be naive and look at only one area. We got to be very careful about the overall cost. So there is a cost of doing it, and it varies between, a certain percentage, maybe 16, 15, 20% of the cost, but that's going to be the cost we pay for it. But there is another cost involved in this, and I firmly believe that that cost of programming test starts coming down, especially when we have the test infrastructures in place, a way to write test in place. Then we don't have to expend as much effort setting these up. In an initial project, we may have a bit more setup time, but once we have things rolling, it's an incremental cost we can keep up with. But there is also the cost of learning. Imagine you are going to work every day, and as you go to work every day, you see a person walking on the street, and a few months into it, you walk into this person, you run into this person at the grocery store, say, hey, I've seen you walk in the morning when I go to work. And the person says, oh yeah, that's right. I've got to walk to work every day. It takes me an hour each way. You say, oh my gosh, an hour each way, where do you work? And you realize that it's not very far at all, but the person has to take all this time to walk. And you tell this person, you know what, actually to get there is much easier if you cut across this way and ride a bicycle. You can get there in 10 minutes rather than an hour you have to walk. The person feels excited. It's like, wow, it's going to save me 50 minutes each way, just 10 minutes on a bike ride. Absolutely. If you don't have a bike, I recommend you go get one. Well, a couple of weeks goes by, you see this person again walk to work, and a few weekends later, you run into this person again, and you say, how's it going? I saw you walk to work again. What happened? Why didn't you try a bicycle? And the person says, that was a silly advice. Look how much bruise I have now, and I have to deal with all this pain. And that's when you can begin to realize that this person doesn't know biking at all. Well, a person who doesn't know biking is not going to take 10 minutes to ride from point A to point B. They first have to learn to bike before they can get around. Same thing with driving a car. For a person who doesn't know how to drive a car, it doesn't take 20 minutes to go from point A to point B. They would be immobile if they don't know how to drive. So that's one of the biggest challenges with test-driven development. But it's even worse because we as programmers, as we gain experience, we know how to write code, and the more experienced we become, oftentimes, not always though, but oftentimes, it becomes really hard to change our ways and start writing automated test cases. So it is not just about learning to write test cases. To do TDD, there is an active part of unlearning involved in it as well. And as long as we are not willing to unlearn and change our behavior, it's really hard to adopt to test-driven development. So a lot of teams failing at test-driven development is because they are not able to invest that time and the learning curve and the unlearning curve to go through. And once they go through that, how much time does that take? Well, I'm really sorry, I don't know the answer for that. In my experience, an empirical result is anywhere from 6 months to a year of investment is needed before we become very proficient with doing test-driven development. This often happens by pairing up with somebody else, maybe a coach, and having them pair program with us and start doing things using TDD, hit walls and try to figure out how to actually write test cases in these cases. And then we tend to understand how to really work through the intricacies of test-driven development. So that investment is definitely necessary. So there's a cost of doing it, but there's a cost of learning and unlearning before we can do it as well. However, there is also a significant cost of not doing it. And this is something we tend to ignore quite a bit. We fail on projects. We got enormous bugs to work with. And there's a cost of maintaining the software. And we make a change and something that worked before does not work anymore. How do we deal with all of these? Well, that's a cost of not doing it. Well, Einstein says the definition of insanity is repeating what we have done over and over and over and expecting a different result the next time. So the cost of not doing it is enormous. I'll share with you some personal experiences in this area. When I was writing the Groovy book, I was going to write the book. Most of the books I write in about 2-week period. So usually the week of Thanksgiving and the week after are wonderful time to write books. I literally shut the door. My kind family slides food under the door for the 2 weeks while I don't see anybody but cram and write the books. Well, when I sat down to write the first edition of Groovy book, I really had this 2-week window. So I had to cram through and write a lot of stuff that were in my mind. But as I sat down to write it, I came across this email from Eric Hatcher, a good friend who has written books like Lucene in Action and Ant in Action, and he said every single line of code in his book has been automated and tested. This was like a godsend message for me. I said, I want to do that as well. And so I took some time, a couple of hours, to figure out how to write automated tests on all the code in the book. It's not simply a unit test because I want to keep the book exactly the way the book would be to the eyes of a reader, but I wanted to get all the outputs and run tests on it. So I had to reach in and mark out things like print statement, which was not too difficult to do in Groovy in hindsight. But the point really is I wrote all these automated tests. Well, what's the benefit? Well, the first benefit is there were a few things that didn't quite work. I went to the mailing list for Groovy and said, I don't have these things working. What's up with this? And very kindly they reported. For one of them, they said, well, you're not wrong. You found a bug in the language. We'll fix it. Another one, they said, well, the documentation is wrong. We'll fix it. For a third one, they said, your understanding is wrong. So I had to go fix my code. So that helped right away. As the book went through technical reviews, people started suggesting changes and improvements to code, and every time I made changes, I made sure everything is still working. Well, even though I wrote book in a short amount of time, it still takes about 4 to 5 months to go through the production process, from the technical review to copy editing to development editing to typesetting to all those things that has to happen. And by the time this all happens, well, my publisher Pragmatic Programmer have such a wonderful way of working. You can make reasonable changes even until the last moment. So the email from them tells me, we're going to go to publication on Monday morning. If you have any changes, report before 8 a.m. Well, I went to Boston to teach a course, and as I was getting ready to teach the course, I had a very late flight. 2 in the morning, I land there, check into the hotel with my class starting at 8 o'clock. What's the most logical thing to do at 2 in the morning, 2 in the night, when you have a class to teach in a few hours? Well, I checked my email, and one email says a new point release of Groovy has been released. Oh, darn it. What do I do now? The book is going into production in a few hours. I download the version of Groovy, ran all my automated tests, and on the window it says all tests passing. Well, that amount of confidence that everything in the book is still working. And all I had to do was just log on and change the point release and say, hey, the book is now compatible with the latest release as of this morning. So the printed copy that comes in 2 weeks is based on the current release, how rewarding that is. Well, even if things did not work, I would know exactly what's broken. And to me, that is extremely important, to be able to run these tests and say, I got 7 things failing. I need some time to fix those, rather than saying, I don't have a clue what's broken. I got to manually go exercise each one of these to find out. So to me, this is one of the most important things when it comes to doing development. And this is the same thing I do in developing software as well. For applications I have in production, the applications where I've written with no automated tests are the systems where I convince my customers that such a change is not good. For applications I have in production where I have full slew of automated tests, I'm able to make releases much more faster. Like a few weeks ago, I had a request to add a particular feature. Well, within 15 minutes, I was able to not only add the feature, but run all automated tests and get a feedback that everything still works. And I didn't break anything in there by adding this feature. And to push this to production with confidence is enormous. With that kind of confidence, we're able to walk with our head up, knowing that what we did before continues to work as we make change to software. That to me is extremely important. Because without it, I'm sure you have seen your share. You go to a programmer, ask them to make a change, fix a bug, make some enhancement. They say they are done. And then you ask this dreadful question to them. You ask them, does it work? And what do they say? They kind of say, well, I hope. What is that called? Well, that's called JDD, which stands for Jesus-driven development. Well, don't get me wrong, I do want to put faith in the Lord, but the Lord is way too busy than taking care of my silly code. I would rather do TDD than JDD because I want that feedback loop that the code that worked yesterday continues to work today. And the reason for that is software always deals with entropy. Things tend to fall apart, things change, things go bad, things evolve, and things that worked once don't work anymore, and software is never actually done. We keep maintaining and improving the software along the way every bit of the time. So as a result, we need to really focus on having these automated feedback loops. Well, when it comes to designing software, when do we really apply test-driven development? Well, we got these two types of design, a strategic design and a tactical design. Please refer to previous presentations on this topic where we talk about strategic and a tactical design. Well, test-driven development fits nicely into the tactical design phase. As we conceptualize what we want to build and then sit down to start building, writing the code, we can refine the design further and start building these tactical details along the way. And TDD helps us to drive this tactical design. So we don't conceive the entire design in the tactical design phase, but we conceive some ideas in the strategic design phase, but then we come back and refine it and evolve it, and TDD can help us a great deal with it. But okay, that's great, but why should we automate? Let me start out first by saying I am not telling do not test manually. So I'm going to say do perform manual testing, but sparingly. So manual testing is incredibly valuable. I was developing an application where I was running full suite of automated tests. And I had gone for literally about half a day to 1 day when I did not bring up the application at all, and all my automated tests are still running. And that starts to give confidence, but after a while you begin to doubt that confidence because you haven't really run the application. So I decided to run the application, to bring it up and start interactively working with it. And sure, everything that I had done worked. However, the first instance I brought up the first page and I'm staring at it and looking at what values to enter, so many thoughts come to my mind. Oh, this could be much better by arranging it this way. This is not very intuitive. Oh, it'll be so much easier if the user is given these kinds of facilities to enter data. Oh, the button should rather be here. Oh, I should really change the color of these things. It's very difficult to automate these kinds of feedback, and so manual testing is extremely important, but do it sparingly. Do manual testing the very first time you create a feature. Do manual testing the first time you see a feature as a tester. So I want you to separate two words in your mind. Separate the word testing from the word verification. We're going to loosely use the word automated testing, but anytime we use the word automated testing, we really are meaning automated verification. In other words, to test if the code is intuitive to use, to test if the buttons are really placed properly, exploration testing, performance testing, usability testing, acceptance testing, a lot of those would have to be done manually. But verification, to ensure that what worked yesterday continues to work today, we don't need manual testing for that. We need manual automated or automated testing or automated verification for that. But why should we really do automated verification for those things? Well, you go to companies and you talk to them and ask them how much automation they have, and they may quickly tell you, well, it's very hard to automate a lot of stuff we do, and as a result, we don't automate anything, is usually the answer we get, which is not a good answer. So rather than saying we cannot automate everything, let's automate everything that's possible. And what is possible is debatable. And I heard this quote, and I don't know what the source of the quote is, but the quote is, don't confuse your inability with impossibility. So the point really is, you don't know how to do things. I don't know how to do things. But you and I sit together, you ask a question, I say something, you again say something, I say something else, and suddenly you say, hey, wait a minute, why can't we do it this way? And suddenly we found a way to do it. So impossibility is very steep. Nobody can solve it. Inability is so rewarding because we can become able and find ways to solve it. And a lot of these things are skills we end up developing over time. So that is one of the reasons why we need to do it. So if you don't know how to do automated testing, it is important to figure it out and get better at it. That is extremely important. But if we don't do, what's the consequence? Why should we do automation testing? Why should we automate? The reason is, with any complex software, we possibly cannot keep up with a change by manually testing every sequence of path of the application. Software is a nonlinear system. You change something here and something breaks over here. So when you evolve the code, fix a bug, make an enhancement, how do you know things are actually still working? Well, the only way you can know that things are working, unfortunately, if you don't have automated testing, is to manually run through the entire application, giving different sets of data. If you give this data, this should be the behavior. If you give a different data, a different behavior is expected. Now you got to test different permutation and combination. We as human beings suck at doing this because we cannot be fast enough to try these permutation combination. Machines, on the other hand, are extremely fast. They can quickly turn around and try different permutation combination, and they can validate to make sure the results are actually correct. If I have to try these combinations, A, it's hard for me to try these combinations, and B, it's error prone when I manually verify that the code is actually doing what it's supposed to do. This also leads to projects that eventually become waterfallish. Let's say we have a project we are calling as agile development. In the first sprint, my team is going to do 4 stories. Well, I go to the testers and say, how much time you need to test it? The testers want 2 days to test it. Well, that's great. We can give them the 2 days. Now we have 4 stories in the first sprint, so we give them 2 days. Well, in the second sprint, the team is going to do, let's say, also 4 stories this time. I go to the testers and say how much time you need for testing, and guess what the testers say? Well, do the testers say they need 2 days to test? Not at all. They probably say they need 5 days to test. Wait a minute, we just added 4 stories. Last time when we did 4 stories, you needed 2 days. Why are you asking for 5 days this time? Well, the reason for that is they have to test the entire application, all the 4 stories now, and that's regression testing. Anytime a programmer even thinks about modifying code, the tester has to start testing. Well, now we go through the third sprint, and in the third sprint, let's say the team implements 5 stories. And what do the testers want now? Well, they want, in this case, potentially 8 days to do the testing. Well, very quickly, when we come to the nth sprint, we realize there is no way we can keep up with it, because the testers say they need a sprint or more to test all the code, all the features. Well, they not only say they need a sprint or more, they say every time the code changes, the clock resets and they need a sprint or more to start testing. Well, as a manager, what can I do? I look at this and say, wait a minute, I got an idea. Let us give the time the programmers need. Let's go do coding. When they get to code freeze, we'll come to you testers. Well, what's that approach called? Well, we call it agile, don't we? But essentially it becomes waterfall, unfortunately, because we are postponing the testing for the code to stabilize. And the sign of this is we're doing way too many manual verifications. But if the tester does manual testing once and extracts everything that can be manually that is being manually verified and extracts them as automated verification and authors test cases for a machine to run, then every time the program modifies the code, the automated scripts can run the test. The tester is no longer needed for that purpose. The tester can now focus on authoring more test cases for various combinations and permutation based on the problem domain. And the investment here is the tester works towards improving the product by giving valuable feedback, by authoring test cases, by running manual tests that are to be run manually, like for example usability and stuff like that, and leave verification to the system to automatically verify. Then we could probably sustain agile development. So that is why it's extremely critical. So one of the tenets of testing is the job of a tester is to manually verify once and automate the verification for future executions. That becomes extremely important. So automation is extremely critical. Well, that's great. Automation is critical, but what are the different types of tests we're going to write? Well, there is the white box testing, and the white box testing is where the tester is keenly interested in the design and the implementation of the code. So this is why usually programmers do unit testing, because unit testing falls into this category of white box testing. Then comes along the black box testing, where the tester doesn't care about the details of the implementation or the design of the code, but the tester is interested in the external behavior from the point of view of the application, the problem, the domain. This is usually where business analysts and testers are involved in. So unit testing is generally a white box testing. Functional and acceptance testing normally is black box testing. And these two types of tests are very critical. You could even argue that in this case, the white box testing probably is in the bottom level of feedback cycle, and black box testing is in the external feedback loop as a way to verify the code is doing what was expected of the code as it was before. Well, with that said, why or where do we automate and where should we not automate these test cases? Well, let's talk about that real quick. For example, if you go back to this picture here, we could have different layers in an application. We could have the classes, the controllers, or the services, and then the UI level. Well, at the very bottom is unit testing. Now, unit testing is on a unit of code. A unit of code is the smallest piece of code that does useful work. So in this case, here is the unit test. On top of that could be things like fit, which is framework for integration testing, and you could look at other BDD tools like RSpec, Cucumber, and tools like SpecFlow for .NET and stuff like that. These are tools that can help us with functional testing and higher level testing, acceptance testing. Then on the UI level, there are tools like Selenium and Water that can provide us automated testing at the UI level. So you could say that unit testing predominantly is focused on meeting the programmer's expectations, and all the other tests combined are focused on making sure the program is meeting the customer's expectations. So these two are extremely critical for us to achieve. But one of the things where we get dragged into is when we try to develop these tests, we got to be very careful where we write these tests. If you look at this particular example here, writing tests at the UI level is really dangerous, and there are problems with it. So to understand what the problem is, let's look at these levels in software for a second. When we have these different levels, we could be writing tests at various different levels of this software. Well, if we write a lot of tests at the UI level, well, let me say that there are three kinds of companies out there. The first kind of company is no automation. This is where the real trouble is, and a lot of significant portion of the industry is right here, where there is no automation. So when there is no automation, manual verification takes over, and it becomes extremely slow cycle and error prone, and a lot of companies get stuck into this vicious cycle. The second type of company is automation. Very critical, but unfortunately what they do is they go out and say, we want to automate, but their programmers are not willing to automate the testing. Well, automate the verification. The programmers say, hey, we don't care. We write code. We've been writing code for a while. Don't bother us. You do whatever you want to do, but leave us alone. Well, unfortunately, what do? The companies? They go hire what are called automation engineers, as they are called sometimes. And these people come over and say, we're going to automate the heck out of this system. And they ask for help and they don't get much. So what do? Well, unfortunately, they start automating at the UI level. So most of the automation code sits at the UI level. Go talk to teams, ask them, what do you predominantly use for automation? If they use words like Selenium or UI toolkit or UI level testing, that is a sign. This kind of testing is often called as the pathway to hell kind of testing. The reason it's a pathway to hell is these tests become very brittle quickly. The UI is something that changes quite heavily, and most of these tools are not capable of dealing with the UI. The testing becomes very brittle. A slight change in the UI can render some of these tests very quickly. If the test especially depends on a certain timing of inputting something into the UI, maybe a JavaScript running or other things running to populate a certain data, the test becomes very brittle with this timing. The test can become very slow, and also trying to set up end-to-end testing at that level becomes very tedious, error-prone, unpredictable, and the tests end up failing quite often. So when I see companies often do this pathway to hell testing, all their test investments that they put at the top level goes bad over a few months, and they usually tell me when we used to run our automated tests, and when you query them, they say they don't run these tests anymore because those tests broke and they have not had a chance to keep up with it. A better way to test, this is where the third type of company that come in, automation at the right level to the right measure. So this is extremely important to follow. Automation at the right level and to the right measure becomes extremely critical. So what you want to do is you want to do as much testing at the lower level as possible than at higher levels. Mike Cohn talks about this in his book, and he talks about the first one as an ice cream cone, and this is the pyramid structure. A pyramid or testing pyramid has to be this way and not like an ice cream cone. So if you have more tests at the bottom layers, we got a very quick feedback loop, and the test at the top level, I'm not saying don't test at the top level, but have those tests minimum, mostly a smoke test, a connectivity test to make sure things are wired properly. For example, in an application I was working on recently, I had to pull some data and display it with a certain set of parameters. So I wrote the code and I wrote the test at the low level for it, in the middle level and in the UI level. So I got tested all the three levels. My UI level test said, go make this query, and when the response comes back, make sure these little data are visible on the screen. So very light little sprinkles of what to expect. The code at the controller level was pretty intensive. Does the user have permission to access this? What do you do if the user doesn't have a permission? What do you do when a request is made but no data is available? All those kinds of details. At lower level, a lot more of these. Now clearly, user not being logged in was not a functionality I could handle at the lower level, but getting the data from the database, stripping out all the necessary details, transforming the data accordingly, all that was done at the lower level. A couple of weeks later, I found out I need to display this data in a sorted order based on different criteria depending on how the request came in. My initial thought was, oh, I'm going to start writing tests at the UI level, and that mere thought was so dissuading. I said, oh no, I don't want to be writing tests at the UI level. Well, if you write tests at the UI level, chances are you have the code for it at the UI level. I quickly realized I don't want to put the sorting code in the UI level anyways, and I started thinking, where would I put the sorting code? And it turned out that I could actually put the code at the very low level. It was immediately refreshing because I could write the test at the low level for the sorting, and the code is right at that level, and that tells me I can get a very quick feedback loop. I don't care to do this testing that things are sorted in the top level, because if the data is sorted in the bottom level, there's no other way it's going to get displayed at the top level. I don't have to really spend my time testing at the top level for that particular thing. So in my application, I have a lot of tests at the lower level, fewer tests at the middle level, the controller level of the service level, and a lot fewer tests at the very top level. Again, it's not zero at the top, but a lot less than what it is in lower levels. And so to follow this test pyramid is extremely rewarding. Well, this is all great, but if we really want to do automated testing, what do we really need? Well, there are a few things we definitely need, but the top of the list is discipline. And without discipline really, right? So discipline really becomes so critical that without discipline, nothing really works. So the discipline is very important. The second thing is learning and unlearning. These two are very important. Well, without discipline, We don't have the desire to really do the hard work. We try a few things, it doesn't seem to work, or this is really hard, oh, I don't really have time, move on. So it's easy for programmers to complain that management doesn't give us the support, but professionalism has to kick in. If we don't have the discipline really to work through it, it becomes very easy to give an excuse saying, I would do this if I was given the support I need. So that kind of discipline is needed for us to fight through and say, this is the right way to do, and we need the time and effort to do it. And also the willingness to learn and unlearn, to go to a colleague and say, hey, can you critique this code? How could I write better tests for this? To find a coach, to find a mentor and say, could you please critique this for me? And have that feedback loop going becomes extremely critical. So the most important thing needed is discipline. Well, if TDD is so important, then why is it not very popular? Well, I'll answer that question tangentially by giving another example. I could be in a large room with a lot of people and I could ask them, how many of you think that exercising is good for health? And almost everybody would raise their hand and say, exercising is good for health. But if you then ask them to keep their hand up, if they actually exercise, you'd be surprised how few people actually keep their hands up. Well, why is that? Well, I can definitely tell you that from my own experience. When I was relatively young a few decades ago, I was running around, writing code, doing work, really working hard, but exercising was not something I really cared about. My wonderful wife kept telling me, you got to exercise, that's good for your health. And I told her, are you kidding? How could I be exercising when I got bugs to fix, when I have presentations to create, when I have code to write, when I got project deadlines, when I got all these things to work on? Well, after trying really, really hard for a long time, she finally ignored and said, whatever, what can I do? Well, then again, she came back one day and I came home, opened the door, and right in front of me was a treadmill. I said, what's that? And she said, well, that's a treadmill. Yeah, of course I know that's a treadmill. Why is it here? Well, she said, you don't have to go anywhere. You can just get on this and exercise. I said, I got it. And I took the back door to come in from that day. Well, the point is, it was not something that I wanted to do. I didn't have the discipline or the desire to do it. Well, a few years went by. I was coming back from one of my trips. Late in the night driving from the airport, my body was beginning to hurt. I kept with it for about 3 months and only every day became a struggle. Finally went to the doctor and said, what do I do? Well, the doctor did a lot of tests and said, come back the next week. Here are some pills to take. Well, when I went back, he said, everything here looks great. You don't have any problem at all whatsoever. You probably had some muscular cramp. With the medicine I gave, you should be okay. Well, definitely not. I was still hurting and only in more pain. Well, the doctor said, well, I got a suggestion for you, but I'm not sure if you want to follow it. I said, I don't care how much money it costs. Tell me I want to do this. I want to get better. I got a lot of fun stuff to do, and this is holding me back. He said, don't get too excited, but nothing really, complex. Just for 30 minutes a day, just go on the treadmill. And I look around, my wife sitting there, rolls her eyes and says, I told you so. Well, the point is, it was a simple recommendation to fix my problem. So I come on the next day, get on the treadmill. I'll tell you that 30 minutes on the treadmill is the stupidest time ever. I do most of my thinking and tweeting when I'm on the treadmill. It's otherwise way too boring. So on the treadmill, I went out for 30 minutes and I went there the second day and the third day. And on the fourth day, what a surprise. No medicines, no pain. And I was excited. On the fifth day, I went on the treadmill, and for a good 2.5 days, I had absolutely no pain. Then on the next day morning, I was sitting and working. My wife comes along. Hey, you're up early. Did you finish exercising already? And I said, look at me. I don't have any more pain. I don't need that stuff. And of course, she was really surprised to hear this and walked away. And the next day, no problem. And about the 8th day, the problem begins to come back. So I go on the treadmill for a few days, the problem goes away. I get off the treadmill, the problem comes back. And then I quickly realized, for the amount of strain that I put on myself every single day, for the amount of running around I do, for the amount of things I do, for the long hours I work, it is almost impossible to be able to do this without really giving what the body needs in terms of the exercises that it needs. So the exercising is the investment, the 20 minutes, the 30 minutes I'm on the treadmill, the most boring time, is an investment for the rest of the day so I can be energetic and get things done. So the point really is, I'm going to say that unit testing is the software equivalent of exercising. Most people know that automated testing is good for the health of the application, the software, but very few people have discipline to do it. It took me several years to attain the discipline, both for exercising and for test-driven development. Carolyn Schroeder says most people do not change when they see the light, they change when they feel the heat. Well, I hope we have felt the heat in our experience. It's time for us to have the discipline to make the change. Like Uncle Ben in Spider-Man said, with great power comes greater responsibility. So it is for our professionalism to turn what we do and develop this discipline and develop the skill to do automated testing. We'll learn some of the practices and techniques in the next series of presentations, but something that you can only work on is to inject that discipline and professionalism in your work environment, starting with each one of us first, and then to the team, and then the reward follows after that. I've seen it in my own personal experience, and I'm committed to this, and every single line of code I write today, I write with automated tests, not because of anything else. In fact, I want to emphasize it. I don't write automated tests because I have a lot of time. It is because I don't have enough time. So I am extremely busy. I've got way too many things going as anybody else's. And if things I create don't work, I should be able to spend the time in the night fixing my own mess or hire somebody else to fix the mess I created. I would rather spend the time creating more value than fixing the mess I created. So I do automated testing because I don't have time, but also because I've taken the time to develop discipline and to develop the skills, and I hope you will as well.